Okay, Ray made and sold ice cream and he wants to predict how much he needed to make each day. He believes he sells more when the weather is hotter. He recorded the maximum temperature and the ice cream sells every day for 8 days. The results are summarised on the table. Draw a scatter plot of this diagram, okay? So what you're going to do is just going to do your 2 lines up and across. You're going to have the thing is with scatter plots is it doesn't really matter which is the x and the y axis. It actually doesn't matter. So for the most part, what one did you put on your x axis? Temperature on the x axis or come on guys, see it? X for temperature, y for sales. That's perfect. You can do it both ways around, okay? Now this one goes from 60 up to 130. So we start off at 60, and we can make maybe every 2 worth 10, 90, 100, 110, 120, 130. Please label it. You don't get marks unless you label it. So sales in euro, is it? Okay. Now the temperature. The lowest value of temperature is what, guys? 14, isn't it? So let's go from 14 up to 24. Let's go up in gaps of 2 as well. So 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Okay, we got to put in our points now, okay? First point is 16 and 80. So 16, 80 is here. Next one is 15 and 70, which is here. Next one is 18 and 80, which goes here. Next one is 14 and 16, 60, which is here. The one after that is 121 and 100, which will go there. The one after that is, actually I have to go up to 25. Is 25 and what number, guys? 25 and 150. Oh, sorry, I forgot about 150 there. So 150 would be up here. So yeah, it's not ideal. Sorry? Yeah, I'm just doing it in order though, so money here. So 23 and 130 is... Now if I was in a test, okay, I'd have to redo that. Actually, we would have to rejig everything. Okay. Okay. 24 and 130 is going to be 24 up, 130 there. Now, as you can see, there's a scatter plot, and in general, the gist is as temperature goes up, so does your sales. That's what the line means. As temperature goes up, so does your sales. Try and put a line middle of the way through, okay? Now, yeah, work away. Now these ones here, we're saying, do you agree with Ray's claim? Do we agree with Ray's claim? We do agree with Ray's claim, because as the temperature gets higher, in general, so does the sales of ice cream, as seen by the graph going upwards, the line going upwards. Ray can use the graph to predict sales depending on the temperature. Can you estimate what his expected sales would be on a day of 22 degrees? Well, 22 degrees, all we got to do is draw it up until it hits our line and go across. Now remember, it's an estimate. So I reckon on a 22 degree day, he should make just over 115 euro. So say about 117 euro. How many people got in the ballpark of 117 euro there? Okay, that's pretty well done. Alright guys. One measure of personal fitness is the time taken for an individual's pulse rate to return back to normal after strenuous exercise. The greater fitness, the shorter the time it takes you to get back to your normal resting pulse rate. Pat and Nora have the same normal pulse rates, followed by a short program of strenuous exercise. Both record their pulse rates P and T at times T minutes after they've stopped exercising. Nora's results are given on the table below. So this is Nora, and draw a scatter graph to show Nora's data. Okay. So what we do here, need to do is do a scatter plot for both of them. Okay. So if you haven't got it done yet, keep doing it with me now while you're waiting. Everybody's had this diagram done. Okay, first of all, what's the maximum and which axis should we use for which? Which one did you do last night? What did you use for the y-axis?
0.5 to 5.
So the x-axis was the time, was it?
Yeah.
And the y-axis? Pulse rate. Okay, now first question I had to ask you is what's the time going up in?
Yeah, sure.
Yeah?
Doesn't matter which way it around.
It doesn't actually, no. Okay, so 0.5, okay, goes up in 0.5, 1, 1.5, 2, 2.5, 3, 3.5. How many? What's the maximum number of time? 5, 4.5, and 5. So right on the dot of the amount of space I had. Okay, guys, what's the pulse rate range from? 71 all the way up to 125. Now, I think what I'm going to do is I'm going to do it in blocks of 3, but each tree is going to be worth 10. 100, 110, 120, 130, 140. Lads, how much is one of my small blocks worth? If 3 blocks are worth 10, how much is one block worth? 3.3 roughly, right? So let's do the points now, okay? So can somebody just call me out the points as we go along? So what's Nora's first point? 0.5 and?
125.
0.5 and 125. Okay, around here. Next one? 1 and?
113.
130. 113, sorry. 1 and 113. What's the next one? 1.5 and? What?
102.
And 102. Okay, next one?
94 and 2.
94 and 2. 94 and 2. Sorry, give me a sec. 3 and? Oh, sorry, 2.5 and?
3 and 81.
Did you not do 2.5?
No.
3 and 81. Yep. Next one?
4 and 83.
4 and 83. 4 and? 83. Okay. After that? 5 and?
71.
5 and? 71. Okay. Now, we can see here is, if we put a general line through the full thing, okay, you can see that's not a great fit. About here-ish, isn't it? About there.
Yeah.
Halfway through everything.
So you just actually estimate where you want the bottom.
Yeah, I'm actually going to show you in the next chapter. I'm going to show you a really technical way of doing it that works perfect every time. At the moment, we're just getting a general feel for it, okay? Now, once we have this done, okay, lads, it goes. Patch results are given on the table below. Use different colour pen, but plot the scatter plot for Pat's on the same diagram as Norris. Okay, guys, so can we do Pat's one now, please? Can you call me out patch results, please?
0.5122.
0.5122. Yeah.
118.
118. Yeah.
111.
Sorry?
111.
Yeah. 2.
108.
108. Round here. Okay. Yeah.
96.
For 3, is it?
Yeah.
Yeah. After that?
88.
4 and 88.
Yeah.
Okay. And after that?
77.
5 and 67, is it? 77. Okay. Now, what is the questions they're asking us here? They go, given a reason, state who would you consider to be the fitter. Okay. Shh. Pat's one, which is in green. Okay. Done this. What happens is the green line, okay, which is going to be around here. You can see that the green line tracks very steadily this way. However, the red line acts completely differently. Okay. So the red line which is going to be done here, okay? You see that the red line goes this way first and then sort of drops off towards the end. So what we're seeing is that Nora is the fitter of the two. She has her heart rate goes down a lot quicker at the start. See the drop in the red line compared to the green line? And then it bounces off at the end as she gets closer to her resting heart rate. So Nora is the fitter person because her heart rate drops quicker. Okay? Now what else is there? Is there any outliers in either set of data? Well, I suppose we'll consider this one here for Nora is a complete outlier. Her heart rate went up after it went down again, which doesn't really make any sense. Regards Pat's data, I think Pat's data goes down every time, so there's no problems with Pat's data. Just what's her name?
Nora.
Nora's data. Okay, Nora's data is the problem. Okay.